Thank you for joining me for ASA cluster configuration. As you know, clustering is a form of high availability. If you would like a refresher on HA, I encourage you to watch my ASA high availability video. In this video, we're going to configure a 2-node ASA cluster. I'd like to point out that this uses the traditional ASA image, not threat defense. I'm also going to assume that you've already seen my other ASA cluster video. If not, I'd encourage you to check it out first. In our topology, we'll use a pair of ASA 5500X series firewalls in spanned-etherchannel mode. The ASAs are connected to a pair of Nexus switches. Each ASA will have their own cluster control links. On the Nexus side, these are vPC links. The data links span the entire cluster. To make this possible, they use spanned-etherchannel on the ASA side. The Nexus side uses vPC. We're not going to look at how to set up vPC on the Nexus switches in this video. If that's something you'd like to see first, check out my other video on vPC configuration. Port channels 101 and 102 are used on the ASA for the cluster control links. We'll put the data interfaces into a port channel. This interface is divided into sub-interfaces. These will become the inside, outside, and DMZ named interfaces. Configuration is going to take place in 5 parts. Firstly, we'll look at the Nexus configuration. As already mentioned, the vPC domain will be pre-configured. Next, we'll prepare the ASA for clustering. This includes setting global parameters and configuring the interfaces. Third, we'll look at the actual cluster configuration. We'll also have a look at a few settings that can be tweaked. And finally, we'll see how to check cluster health, enable and disable members, and so on. Before beginning, we need to verify the port channel load balancing type. You can see here that source and destination IPs, as well as port numbers, are used. If this was set to something unsuitable, like source and destination MAC, we would have to change it. On the Nexus side, we'll create VLAN 100 for the cluster control link. There are 4 interfaces per ASA used for the cluster control link, 2 in each Nexus switch. In this lab, they connect to FEX ports, which is why the interface numbers look a bit odd. The interfaces for ASA1 are added to port channel 101. Remember that the MTU needs to be set higher on the CCL interfaces to allow for extra overhead. In this case, we're going all the way up to 9,216 bytes. To make the port channels work across the pair, they're configured with a vPC identifier. The process is repeated for the cluster control link on ASA2 using port channel 102. There are also 4 data interfaces per ASA. All interfaces are added into port channel 100 on both switches. As this will use sub-interfaces, this needs to be a trunk port. We also need to disable LACP graceful convergence. This won't apply while the interface is up, so it needs to be shut down first. Setting fixed hash distribution also requires a link flap. It's easier to configure while a link is still down. For more information on why we're messing with LACP, have a look at the article on the Network Directions site. That's it for the Nexus switch. On to the ASA. There's a few settings to get right on each ASA before we add it to the cluster. The first is jumbo frames. This is to support the larger packet size on the cluster control link. Next is the interface mode. Individual interface mode is set by default, but we need to change it to spanned-etherchannel. The check details command confirms that there's no incompatibilities that would get in our way. Once this is set, the ASAs are reloaded. I'll cut out the reload process to save your time. I have another video showing the full ASA boot up if that's something you really want to see. After the reboot, we can configure the data interfaces. Each interface is added to port channel 10 and configured with a VSS ID. The VSS ID tells the ASA which Nexus switch this port is connected to. The same port channel number needs to be used on both ASAs. The span cluster keyword identifies that these interfaces are in spanned etherchannel mode. VSS load balance tells the ASA that the connected switch is vPC aware. This essentially enables CLACP on the interfaces. Sub-interfaces are created and configured, which are all very straightforward. The only notable feature is that a virtual MAC address is created for each interface. This VMAC is the same on both ASAs. Notice that the data interfaces stay down. This is normal. They will come up later when the cluster is configured. Alright, it's time for the good stuff. This is what you came here for. Let's get the cluster underway. We're going to start by creating a pool of IP addresses for management. All up, our cluster will use 3 management IPs. There is one for each ASA, as allocated from the pool, and an additional IP for managing the cluster as a whole. The cluster IP is assigned directly on the management interface, along with the pool created earlier. It's now time to add all the CCL interfaces into a port channel. Now the part you've been waiting for. Let's configure the cluster. We'll start by giving it a name. Each member in the cluster has a local name as well. This is used in troubleshooting and syslogs. The cluster interface is the cluster control link. We tell it which interface to use and assign an IP address. The priority is used to influence the election of the primary unit. The key is optional, but is recommended for security. Finally, enable clustering on this unit. This warning shows any incompatible configuration we have and confirms that we're happy to remove it. The cluster begins the election process. Notice that there can be no config changes until there is a primary ASA. Eventually, this member is elected as the primary. This is not really surprising, as it is the only cluster member. We're now free to set the MTU. The configuration is repeated on ASA 2. Once clustering is enabled, the configuration is replicated from the primary, and this member becomes the secondary. You might notice that master and slave are shown in the output. The documentation is moving towards using primary and secondary terminology. For ease of troubleshooting, it's good to have all console messages on secondary units replicated to the primary. The members send health messages over the CCL every 3 seconds. We're going to keep the default timer, but we're going to tell the cluster that it's connected to vPC enabled switches. This helps prevent the ASA from thinking that the cluster is down if one switch reboots. Connection rebalancing allows an overloaded member to pass off some connections to other members. I'm only doing this to show you how it's done. I wouldn't actually recommend using this in production. Have you noticed that we're not making any changes on the secondary? Now that the cluster is up, changes are only made on the primary. Let's take a few moments to verify the configuration. Firstly, use Show Cluster Interface Mode to confirm that we're in spanned-etherchannel mode. Use Show Cluster Info to see the cluster members. This will show the state of the current member and which one is master or primary. Show Cluster Info Health shows us the state of the cluster as a whole. In our case, the cluster is healthy. We can see the interface state for each member as well. Let's get a bit more proactive and remove a member from the cluster. This is done by entering cluster configuration mode and typing in no enable. The ASA transitions to the disabled state, and in this case, another member is elected as the primary. The cluster still shows as healthy. This happens because the member was gracefully removed. The ASA cluster does not see this as a member failure. Let's put it back into the cluster now. Notice that it does not automatically become the primary, even though it has a better priority. This is because there is no preemption in the cluster. We can manually make it the primary with the cluster master unit command. As soon as it's ready, that is. The cluster remove unit command can be used to remove a remote unit. This is useful if you don't have console access to it. Okay, now let's put that back in. Finally, use the cluster exec command if you need to run a command on a remote unit. So that's it. Your cluster's all done and you're ready to go. I hope you've enjoyed this video. Let me know what you thought in the comments below. And don't forget to subscribe or follow me on Twitter to find out about new videos and articles. Thanks again for watching.